All right, my dear children of class 11 science, we move to the important law after the terms that you learned in the last YouTube video. Now, actually in thermodynamics, there are a number of laws. Okay, so like there are the zeroth law of thermodynamics that we are going to learn in this video. After that, we have first law of thermodynamics, second law of thermodynamics. Okay, so, and every law has their own importance. Okay, but the most important case of zeroth law of thermodynamics is it gives the concept of what? Thermal equilibrium of a body. The concept of what? Thermal equilibrium body, and it also gives the concept of temperature. Because temperature is that is a quantity of thermodynamic coordinates, okay, that determine the degree of hotness or coldness of a body. Okay. Now to understand about zeroth law of thermodynamics, this law was actually formulated, okay, by the scientist name R.H. I'm writing the name of scientist R.H. Fowler. Okay, so he was the person who actually formulated zeroth law. But the fact that I'll tell you that this law was formulated by this particular scientist long after the first and second law of thermodynamics, which were formulated, okay, in thermodynamics. Means the first law was formulated, then after second law was formulated, then only after that the zeroth law or concept of temperature or the thermal equilibrium was formulated by the scientist called R.H. Fowler. But in thermodynamics chapter, we start with this particular law known as zeroth law of thermodynamics. Okay. Now you have learned in the last YouTube video the concept of thermal equilibrium. Thermal equilibrium means that state of a system, okay, where the number of state of a system of bodies, when two bodies or more than two bodies are kept in contact with each other, then both the body or the number system of bodies maintain same temperature. And if the system of body maintains same temperature, then that state is called thermal equilibrium of bodies. Okay. Now to understand about zeroth law, okay, so we take there total how many system? Three system, and this system, okay, can be separated by taking the insulated wall and the non-conducting material, okay, and another one is the conducting wall. Okay, conducting what? Wall. So for this particular zeroth law of thermodynamics, let me first take two system. Let me take two system. Okay, and this system I consider say is one is A, another is what? B. And this system A and B are separated by insulating wall. So this is the insulating wall. So there is system A and there is system B, okay, contained in a vessel. Okay, now this system A and B is separated by what? Insulated wall. Okay, so A and B system are separated by what? Insulated what? Wall. Okay, now these two system, okay, now are in contact with another system. Now I'll keep, and this system is basically system C. Let me mark by letter system C. System what? C. And this is system C. And this system is in contact with, bounded by a conducting wall. So this is a what wall? Conducting wall. Conducting what? Wall. So you can see there are total how many system that we have taken out here? That is three system, A, B and C. But out of three system you can see A and B are the two systems separated by insulated wall, and both the system now are in contact with another system C by another wall known as conducting wall. So when we do so, then you can definitely see that there is a state of the system will change. The state of the system will change until both the system A and B, okay, come to thermal equilibrium. Both the system A and B come to thermal equilibrium with C. Come to thermal equilibrium with C means both the system acquire same temperature with respect to the temperature of the system C. This means that in order to achieve this system of thermal equilibrium with each other, okay, definitely there is a transfer of heat takes place from system A to C, also systems B to C also, because this two system A and B with C are bounded by conducting wall, and conductor is a good that substance which can allow the heat to flow. The heat can transfer from between A to C and B to C, whereas it cannot flow from A to B because this is bounded by insulated wall. But after achieving this case of what? Thermal equilibrium of A and B with C, we can now simply replace this conducting wall C, okay, conducting wall or C by the insulated wall. And we replace this insulated wall by the what? Conducting wall. So we just interchange this insulated wall and conducting wall that bounded between A, B and what? C. So children, once we do the interchange of this conducting wall and insulating wall from this diagram to this particular diagram that you can see out here also, okay, that is, then in this case also you can see that the state of A and B change no more. The state of A and B will not change at all. Okay, now they are in thermal equilibrium with each other. This system A and B are in thermal equilibrium with each other. Now this is the basic principle of zeroth law of thermodynamics. Now see, in this particular diagram, system A and B are in thermal equilibrium with C when this is bounded by conducting wall and this is bounded by insulating wall. But in this particular case, when you interchange this wall between conducting wall and insulating wall, okay, then between A and B, system A and B, there is a what wall? Conducting wall. Okay, so under this case, there is this A and B still in what? Thermal equilibrium with each other. The thermal equilibrium with each other means there is no transfer of heat takes place between A and B. Means there is no heat flow from between A and B. If there is no heat flows between A and B, means what happened? Definitely they acquire same temperature. Body A acquires same temperature. System B also system A acquires same temperature. System B also acquires same temperature. Means these two systems are also in what? Thermal equilibrium. So children, this is the basic principle of zeroth law of thermodynamics. That's why this is the fundamental law of thermodynamics. This is the fundamental law of thermodynamics, which actually give you the concept of temperature, because temperature determines the system state of system, which shows that whether the heat flows from one system to other system or not. But this is the case of thermal equilibrium with each other. So definitely both the system acquire what temperature? Same temperature. Okay, that's why zeroth law of thermodynamics state in certain manner. So let me write the statement of zeroth law. And the statement says that if two bodies, that is A and B, we can say a system of bodies, are separately in thermal equilibrium with third body C, are separately in thermal equilibrium with third body what? C, then A and B are in thermal equilibrium with each other. Then A and B are also in thermal equilibrium with each other. Now let me just consider, suppose this body has temperature TA, this body has temperature TB, and this body has temperature what? TC. So as per the statement which I have mentioned out here, this statement says that if temperature of A is equal to temperature of C, yes, if temperature of A equals to temperature C means body A is separated in thermal equilibrium with body C, and if temperature of B is equal to temperature of C, means body B is also separated in thermal equilibrium with body C, then zeroth law says that temperature of A is also equal to temperature of B. Temperature of A is also equal to temperature of what? B. Means the two bodies are also in thermal equilibrium with each other. So in a simple way, I'll tell you that if there are three bodies, okay, then all the three bodies are simply in thermal equilibrium with each other, because all temperatures are equal to each other. Because if TA equals to TC, TB equals to TC, then TA equals to TB, which means this also equals to TA equals to TB equals to TC. We can write this way also. Okay, and this T implies the temperature. This implies the temperature. And this is the statement of zeroth law of thermodynamics. Now the next thing that we need to keep in mind, children, is that all those bodies which are in thermal equilibrium have a common properties. Have a common what? Property whose value is the same. Whose value is the what? Same for all the bodies. Value is same for all the body means like the temperature, which measures the degree of hotness or coolness, is same for all the bodies. So that's why we call this property actually as temperature. We call this property as what? Temperature. So the property of body, when this body acquire same, which is same for all the bodies, okay, under thermal equilibrium, is actually called as temperature. That's why the concept of zeroth law of thermodynamics, children, actually give you the concept of temperature. Thus, temperature is actually that property of a body by which we know whether the body is in thermal equilibrium with another body, okay, or not. So in order to understand whether the one body is thermal equilibrium with another body or not, that is all determined by the property of body with respect to each other, and that is called temperature. That is called what? Temperature. Okay, so this is the detailed explanation of Zeroth law of thermodynamics. Okay, now in the next YouTube video, you learn about the equivalence of work and heat, which is the most important concept for next law, that is called first law of thermodynamics, and that you learn in the next YouTube video.